Antenna gain?
Yes.
Yes. This paragraph here confused me. I'm sorry, in the book. An antenna derives its gain by taking the power that would normally radiate in one direction and adding it to the power that is radiating in another direction. The total power radiated remains the same, but the power in the favored direction is increased by the addition of some power taken from a less favored direction.
Yes.
Not sure what that.
Okay. The best way to explain that to you would be by using a beam, for an example, beam antenna. In the case of a beam antenna, you have a reflector,
8-3. Yeah.
and you have your driver, and then you have one or more directors. Now what happens is you feed this antenna. This is where your power from your transmitter goes.
This is what, an array?
Yes, this is an array.
It's an array.
I'm giving an example of this. I mean, it works similar with vertical antennas, but it's easier to explain this way. Okay. So what happens? This is a dipole antenna, and they radiate the way I just explained it, right?
Yeah.
Okay. So here's what happens. This field also encounters this piece of metal. Okay. Any metal, when it's subjected to a radio field, has a current that begins to flow through it. It's just like your laws of magnetism and generators and stuff. That current, of course, is going to be at the same frequency as what it's being generated at, and it's now going to create its own magnetic field. That magnetic field will be weaker than this one because it's being generated from what it got there, but it will be at the same frequency, and depending on where it meets this field, it will be either in or out of phase. So it either will effectively increase the ability of this radiation in this direction, or it won't. Now this back antenna is deliberately detuned, so it's actually longer than the proper frequency, so that it won't radiate effectively. It will actually dampen it. That way the antenna has lower gain here. So it doesn't pick up as much off the back because it's selectivity. This field encounters another element here. That element begins to radiate. These elements are spaced at the proper distances. There's a formula for it. And each one of those elements are arranged so that when they do generate a field, it's always in phase with this one. So they keep multiplying the effect. And basically you start off with a dipole that would normally do this, and by the time you multiply all these new induced lines, you end up with a pattern. It's more like that, and like this, because they aid each other. So that's how Yagi works, and your ground planes and that work in a similar manner, but it's easier to show you with the different elements. But basically you have all these different magnetic fields, and they either strengthen or weaken each other depending on whether they're in phase. If the antenna is properly designed, then it will be in phase in the direction that you want to go.
Is there a limit to the number of director elements you can have?
At some point, you won't be able to get enough radiation to make it effective. But for example, I had an 18 element Quaggy, and that thing was impressive. I would feed that with 500 milliwatts of power, and I would key up the Pelston repeater. Full quieted, receive and transmit. This also works for receive as well.
So what would the power output be on that?
Effectively, well, it was 18 decibels of gain. So you have to calculate that out. So it's in 3 dB increments. So if you start off, let's say, I'll just go for 1 watt just for the fun of it, and we'll cut it in half later. Say 1 watt, you add 3 dB, that's 2 watts. You add 3 dB, 4 watts, add 3 dB, 8. 3 dB again, 16. So we got 3, 6, 9, 12. One more. So 32 dB of gain. Yeah. 32 watts. 32 watts per 1 watt. So if you knock that down to 0.5, well, it'll be a little bit less, half of that, but still very impressive. Put 30 watts into that antenna. They're going to hear you really clear.
Put 170 in and see what happens.
Put 1,000. This is where your safety code 6 comes in. Now it's possible to exceed those safety code 6 limits, especially if you're pointing into somebody's picture window. That's why you want your antennas high above everybody. When you start dealing with gain antennas, you want them up there, so you don't run into that. Does that make sense?
Yes.
What are some common problems that most amateurs or some amateurs run into when they first start?
Problems.
If any.
Varies it depends on where you're putting your station. Sometimes it's getting a wire up in the air. What kind of antenna can you use? Are there any covenant restrictions? Do you want to draw attention to your operation or not? If you want to put in a significant installation, it'll take some planning. Maybe you might want to consult an engineer, or you may just look at websites that are made by the companies themselves, and they'll tell you what is minimal requirement for their product. If you're a first-time operator, you may have some problems making up your feed lines. Just putting the actual connections on your coax. It's usually a good idea to get the help of an experienced operator to help you set up your station. Because if you get these cables wrong and you short them out, you can blow up your equipment. So you really want them right. And not every amateur starts with the soldering skills to be able to put a connector on a piece of cable.
Always have a match meter.
Match meter's great. If you know someone that's got something even better, the analyzer we talk about, there's a few of those kicking around. I have one, and several other people have them. These things can be put on your antenna system without even putting any power into it. Find out the exact frequency, tune your antenna to exactly where it wants, no carrier on the air, perfect match. When it goes on the radio, it's done.
Where's the cheapest place to get an oscilloscope? Like decent run-of-the-mill?
Depends what you want to do with them. Simple oscilloscope, you get them on eBay, places like that.
Yeah, it's about $70
Yeah, that's around the range.
That's what I was. Well, that's what when I was looking. But it might have been plus shipping because it was.
Yeah, there'd be shipping as well.
Yeah.
Is there a difference between the oscilloscopes?
Oh, lots of differences. There's dual trace, single trace. There's digitally triggered. There's just your old-fashioned analog versions. It just depends on what you want to do with them. What kind of sensitivity do you need? Are you going to work on solid-state equipment? Frequency ranges. Are you going to be working in frequency ranges that are above the range of most scopes? Typical scope is 10 megahertz, what they rate them at. If you're going to work on 100 megahertz systems, you're going to need a 100 megahertz scope, double the price of scope. Older scopes don't have three-prong plugs. Beware. Chassis is hot. Metal case, 2-prong plug. Beware.
Is there a place around here to buy the military surplus, like stuff like that, like oscilloscopes?
Not here.
In the States, probably.
In the States, there'd be lots of them.
One of my teachers
Toronto,
in Ottawa
all kinds of them. You can go down to Toronto, a place called Ford Radio,
Oh, okay.
and you can get all that stuff. That's where all our equipment goes. Ford Radio. Receivers, transmitters, test equipment.
Teacher I had did some contract work for the DOD, and he was in Ottawa, and he had a bunch. He said he had was either oscilloscopes or something else. He had 40, but I think
There's another big one there's another big outfit in Ottawa too.
Yeah.
Yeah, Ford Radio's the big one in Toronto. There's some bunch of ones in Ottawa. Of course, there'd be one in Ottawa. There's treasure trove of government surplus electronic equipment there. Toronto, they have to ship it there, but Ottawa, it's already there.
I think that's where they run the auctions at.
Exactly, auctions. Yeah, you can get them online too as well.
Oh yeah, I guess an auction site, the government auction sites where that's some.
Yeah, you can go right to you can buy equipment directly from the government.
Yeah.
A lot cheaper than you get it at Ford Radio.
Oh, okay.
So basically,
Do you know the website for that, or you just?
You just, government services, surplus, what do they call it? Crown assets. Just type in Crown assets.
Or just go to Google and type in.
And it'll be a Crown asset website. And if you want to get stuff, the best way to get stuff for that, you got to put in bids, eh?
Yeah.
And it's a good idea to be with a friend because the bids are usually on lots. They don't just sell a piece of equipment. So if you want a spectrum analyzer, you got to buy 10 of them. That's the bad news. The good news is that if you put in a bid for $100, you might get all 10.
Yeah.
Just depends on who bids against you.
Seen that with
But
computers.
if Ford Radio gets them, he'll get them for 10. He'll get them for $100, and he will sell them each for $4,000 a piece to you when you go back.
So there's not much of a markup in some of the stuff.
That's what they're worth.
Wow. Oh, okay, so the word. Yeah. So it's just been.
They're being dumped by Crown Assets. They have no clue of what they're really worth. They
And
do-
it's few and far in between for those.
not that far between. Right now would be a really good time. There's a lot of equipment being dumped.
Yeah.
Yeah, so they can make sure they buy it and spend all the money.
Yeah. Our money.
Our school, our school picked up a $4 million laser. donated.
Yeah, the stuff is out there.
Well,
You know where to look.
I guess in the 2000s, when the early 2000s might be good for that too, when all the surplus here in the 80s and stuff.
There was some of that too, yeah.
Yeah.
But the department recently got rid of a whole bunch of older equipment. They moved to the new computer-based test gear. So there's a lot of that stuff that you're talking about is going to be available at rock bottom prices if you get them right from Crown Assets, but you'll be getting them in lots.
That's all full pool.
Yeah.
Yeah, yeah, exactly. Yeah. $4,000.
Any other questions?
I saw a bunch of crown things from there. And
Any subject to do with radios? Anything you didn't quite understand in your teaching so far?
yeah, next week.
I'll be back on Thursday. The other guys will be in on Tuesday. There'll be 3 other guys.
Still 15 minutes.
Did I tell you the story about the Italian radio station in the Flower Gardens? No. I learned this from an FCC inspector who was visiting one time. You know how we were talking about how the radiation from antennas can get into things and cause audio wreck and other little things like that?